So we have to sometimes add and subtract rational expressions, and actually I'll add multiplying and dividing here. So let's say we got this expression, 9m plus 4 over m plus 3, m minus 9. Subtract that by 8m plus 1 over m plus 3. That's a bad 3, isn't it? And then an m minus 9. Okay, so this one is it doesn't look like it, but it's actually an easy one to start off with, okay, because we have common denominators going on here. When things have common denominators, then we can subtract the numerators. So since they're in common, I'm going to subtract this first numerator by the second numerator. And look how I protected it in parentheses. It's because the whole second part of this numerator is getting subtracted. I'm putting quotes down here because it's the same thing. You've got to subtract everything, and that's a big issue for why students get these questions wrong. Okay. Oops. So, yeah, distribute that minus sign. And so, still quotes. It's still the same thing in the denominator, right? 9m minus 8m makes 1m. 4 minus 1 makes 3 over m plus 3, m minus 9, and we're not quite done. We can simplify a little bit more because look, we have an m plus 3 and an m plus 3 in the top and in the bottom. So those cancel out to make, they divide each other. It makes 1 over 1. So this is our simplified answer because of those canceling out. Okay, so that's an example of adding and subtracting. Let me do another one. Let's say you have 4 over x minus 2 subtracted by 3x plus 1 over x minus 3. They don't have common denominators, right? So I'm going to multiply this fraction by the opposite fraction's denominator. So I'm going to multiply the top and the bottom by x minus 2. Same type of thing with this fraction over here. I'm going to multiply the top and the bottom by x minus 3. That way I'll get common denominators. Okay, so let's write what we got left over. We're going to have 4 parentheses x minus 3 when you multiply this top to this top, right? And it's all over x minus 3, x minus 2. And then we're subtracting that by, we got 3x plus 1 times x minus 2. We got to keep that in parentheses. And then we have the same thing in the bottom. We got x minus 3 and x minus 2. So now at least they have common denominators. We still got to do some simplifying though. We got to distribute this 4 to everything inside this parentheses. So this becomes 4x minus 12 over x minus 3, x minus 12, x minus 2. And then over here, if it's been a while since you multiplied two parentheses to each other, just make sure that every term in the first parentheses multiplies to every term in the second parentheses. So 3x times minus 2 makes minus 6x. 1 times x makes 1x. 1 times minus 2 makes minus 2. And there's my quotes again, my laziness. So I don't have to write it out. Okay, so let me take that and move it up here. Give myself a little bit more room. Yeah, to finish this out, now that we have common denominators, now we can subtract the first fraction by the second fraction, the numerators. Make sure you put a parentheses around the second fraction, though, like we did in that earlier problem, right? Oh, I could have combined these. This is minus 5x, right? Negative 6 plus 1 makes negative 5. And then in the bottom, this is x minus 3, x minus 2. We're getting there. Get that out of here. This is where we're at. Now we have to distribute that minus sign. That's a plus 5x now because minus a negative 5x means plus 5x. And that's plus 2 because minus a negative. Same thing in the bottom. And now if you combine like terms, You got 4x plus 5x makes 9x, and actually let's put the minus 3x squared first. That way we have descending powers. So 4x plus 5x made 9x, and minus 12 plus 2 makes minus 10. And then, the bottom is x minus 3, x minus 2. And then to finish this problem out, what you'd want to do is try to factor the top, okay? 30. There aren't two numbers. You can't factor the top with integers. So this is as simplified as this one can go, okay? So that all started with getting common denominators. Like, let's do one more here. I think we've multiplied. Oh yeah, let's actually multiply rational functions. So let's do x minus 3 over x plus 2 times 3x over 2 minus x. If you here, actually, let's make this a little harder. Let's make this division. Okay. Multiplying and dividing rational expressions, the same thing happens. The same rules happen back with our old fraction word, okay? With division, I just changed this to a division problem. We have to start by flipping and then multiplying the second fraction. So this is now times 2 minus x over 3x. And now we can go ahead and multiply straight across the top and straight across the bottom like we've done before with fractions. That's the good thing about multiplying and dividing fractions is we don't have to worry about common denominators, right? And just notice how I'm putting things in parentheses so I make sure to multiply all of x plus 2 by 3x. So if we multiply the top here, that becomes 2x. If we multiply x times negative x, it makes negative x squared. If you multiply negative 3 times 2, that makes negative 6. And then negative 3 times negative x, that makes positive 3x. And the bottom, if we do that distribution, this is 3x squared plus 6x. And then like before, simplify as much as you can. Up top here, we're going to put negative x out front, negative x squared out front. And we got 5x and minus 6. And then we had 3x squared plus 6x in the bottom. So that looks to be as simplified as we can go unless you try to factor. And this one actually you can factor, the one I just made up here. I don't know if they'll be this tricky on your homework, but let me do that just to be complete here. Look at the top. If I factor out a negative 1, that'll make it easier on the eyes. So I factor out a negative 1 from the top. Now I can find two numbers that multiply to be 6 and add to be negative 5, right? How about x minus 3 and x minus 2? Those two multiply to be positive 6 and they add it to be negative 5. But it turns out factoring didn't help us find something 3x squared. Yeah, because the bottom, if you were to refactor the bottom, factor out a 3x, you're left with x plus 2. Nothing actually cancels out. Close, but no cigar. Okay, so nothing cancels out there. But it's a good habit to be in, you know. Once you combine like terms, or once you multiply straight across the top and bottom, just factor. And then, simplify and factor, I should say. Okay, I'll make some videos on some more specific problems, see if I can help you out there.